Okay, Assalamualaikum and hello. So, congratulations on your test one. Many of you can answer the question. So this is just to show you how the solution for the test one. What is the solution for test one? So you can see here. Okay, you have a show system here. You have Z1, Z2, and Z3. Z2 and Z3 is parallel to each other, and Z1 is series with Z1, Z2, and as well as the Vs. Okay, so find the complex power for each load. So remember, you have to recall what is complex power. So for this class, we use TICS, okay, something like this, complex power. So because this is Z1, you just use S1. Okay, so maybe I just list down first the component, so easier for you to check. Okay, for Z1, okay, PZ1 is equals to 1.9 kilowatt, and PFZ1 is equal to 0.89. So you have PF, you have P. Okay, so for this case, I think the shortest way is to use S is equals to P divided by PS. Okay, so 1, 1, 1. So 1900 divided by 0.89 is equals to, so you get 2134.83. Okay, VA for this is apparent power. Okay, so theta is equals to cos inverse PF1. Okay, theta 1 is equal to this one, equals to cos inverse 0.89 equals to so you get 27.13. Always take usually we take 2 decimal point. So now the S1, make it thick, S1, this show it is a complex power 2134 point on S angle theta 1, S1 theta 1. So 2134.83 angle 27.13. Okay, so you get the first one. So the second one, Z2, you have a V2 is equals to 80 for angle -5, and Z2 equals to 3 plus J7. Okay, so the shortest way to find the answer is use the formula. Okay, there are a lot of ways, but I try to use the shortest one. Okay, so complex power, recall back the formula, S2 is equals to, so V2 squared, okay, divided by Z. Okay, don't forget the star. Okay, this one is 2. So V2 squared. Okay, this one a lot of you are making the wrong decision here. Okay, remember when there is a square here, make sure you don't take the angle, only the magnitude. So 80 squared divided by 3 plus J7. Remember there is a conjugate, so plus become minus. Okay, don't forget that. Don't forget the conjugate. So use your calculator. 80 squared divided by 3 in bracket 3 minus 7i. Okay, so equals to 331.03 plus J772.41. Okay, that is how you obtain Z2 complex power number 2. And for Z3 is, you already have the apparent power S is equal to 2300, and PF is 33, and PF3 is 0.81 lag. Okay, so you already have S. Use the same concept. Theta 3 is equals to cos inverse PF3. So you get cos inverse 0.81. Okay, lagging you just leave it like that. Is leading you have to put negative. So cos inverse 0.81. So the answer is 35.90. Okay, so complex power S3 is equals to S3 angle theta 3. So you get 2300 angle 35.90. Okay, so that is how you solve the equation. Okay, for 1a. So next is the total power factor of the circuit seen by the source. Okay, so how to do this? You just add all the power. Okay, so all of the power you just add it. So S total is equal to S1 plus S2 plus S3. Okay, so S1 is equals to, let me check first. Okay, S1 is here, 2134.83 angle 27.13 plus S2, where is S2? This one, 331.03 plus J772.41, and then plus 2300 angle 35.9190. Okay, so you have, so let me pause first. So you have use your calculator, you get 5131.8987 angle 37.08. So you have the angle here, you just use, let me move this. Okay, so theta is equal, not theta, PF total is equals to cos theta total. Okay, theta total is this one, so cos 37.08. okay, so you get 0.7978. so that is how you solve question number 1b. So next is the supply current IS. So how to calculate IS? So you can see here how to calculate IS. The first one for 1C is you have to find the current at Z2. Okay, you can see here. Okay. Okay, you have current here, you have current here, you have current here. So this one is I3, this is I2, this is I1. So I1 is equals to I2 plus I3. So I1 is basically IS. Okay. So you just find both of this current, you get the IS. So for I2, okay, I at 2, you have V and Z. So V2 divided by Z2. So 80 angle negative phi divided by 3 plus J7. So you get the answer is, so you get 3.28 minus 9.98 J. Okay, so you get the first current. How about I3? Okay, so how to get I3? So for I3 you have S and you have PF. Okay, S3 and PF3. So if you recall, Z2 and Z3 is parallel. So actually you have the V2, okay, V2 as a reference. So for this, I think you can use the complex power equation. So let me check first. Okay, yes. So you have to look back. S3 is equals to 2300 angle 35.5 or 9, I think. Let me check first. Okay, yeah, 9. Okay, and recall back as this is complex power equals to VI conjugate. Okay, so from this, I is equals to S divided by V, okay, conjugate. Okay, I think two of you flip this. Okay, make sure you be careful when you do algebra. Okay, so make sure you divide it correctly. So I3, okay, this one is 3, or for this case is 2 because we take it from 2. So I3. So I3 is equals to S3 2. Okay, this one is 2300 angle 35.9. Okay, and divide by the voltage number 2 is this one. Okay, so 80 angle negative phi. So the current is, let me calculate this. So pause first. So you get the second current, the third current. So recall back, IS is equals to I2 plus I3 equals to, okay, let me move this first. So 3.28 from this, okay, minus J 9.98, okay, and then plus to 8.75 angle 40.9. Okay, so the answer is 38.14, okay, angle negative 49.03 ampere. Okay, so you solve question number 1C. Okay, this is IS. Okay, so congrats if you can answer both. So after this, we move on to the question number 2. Okay, so we continue. So a toroid core. Okay, so toroid core, if you still don't know what is it, toroid is just a core that's shaped like a donut. Okay, donut shape is basically a toroid. Okay, it's made of iron and having relative permeability of mu r 5000. So when it comes to question number 2, you have to know how to extract the information. So mu r is equals to pi 1000. The mean path length, or LC, is 37.6 cm. Of course, you have to convert this into a meter, 0.376 meter. Okay, and then the cross section area is AC is equals to 0.1256 cm squared, and of course convert it to meter. So for this one, you just multiply by not multiply, but divide by 1 per 100 squared. Okay, cm to meter is 100 squared, and you get, let me pause this first. So this is the answer. Okay, so next is the fringing and leakage effect is neglected. Okay, so leakage flux, no leakage flux means that all flux is the same, because this for toroid, you see something like this is round, so the flux is all the same. Okay, the same path, there is no leakage outside. Okay, this one doesn't happen. That is meant by leakage, no leakage flux. Okay, or leakage flux can be neglected. Fringing effect is, remember, if there is a gap here, air gap. Okay, if you have fringing effect, area at the core is not the same as the area at the gap. Okay, AG. Okay, so that is means by fringing effect. Okay, but if fringing effect is neglected, so A core is equals to A gap. Okay, so make sure you know what is the meaning of fringing effect and leakage flux. Okay, so we continue, and number of turn coil N1, so N1 is equals to 400 number of turn. There is a gap 5 mm, L gap is equals to 5 mm equals to 0.005, okay, cm. Okay, in meter, of course you have to change to meter, and the magnetic flux density, so B is equals to, and at the A gap, Bg is equals to 0.25 Tesla. Okay, if you don't show what is magnetic flux density, you look at the unit. Okay, so Bg, okay, at the A gap is 0.25. So that is how you extract all the information from the sentence. Now the first question, draw the equivalent magnetic circuit of analog core. So you just draw analog magnetic circuit, something like this. Of course you have to draw the flux. Okay, this is the magnetomotive force. Okay, and then you have the core and the gap, this one and this one. So you have S core and S gap. Okay, that's it, you get 2 marks. And then next, calculate the current required to energize the core. So for this case, you have 2 options, remember? So this one you have to be careful. Okay, you can use either F equals to HL, okay, or F equals to S flux. Okay, so you have to choose one, but for this one you need to have hash information. So if you look here, hash is not given too much. They sorry, this one, capital hash, is only given the area. Let me adjust this. Okay, they give area and length. Okay, and B you can get the flux. Okay, So basically you have to look at the information and you have to choose which one is more suitable. And for this case you have to choose this because this one can go into, you can get flux. Okay, you can also get can get hash, but okay, and then you have area. Okay, usually if you have area and length, we consider this one. Okay, this one also can, but it's a little bit complicated. Okay, you can use the same thing, but it's a bit complicated. So I just show you the simplest equation. Okay, engineering is all about simplicity. You have to find the simplest solution. So choose this one, and of course you have to calculate the S. Okay, S total is basically S cap plus S S core. Okay, S core plus S cap. Okay, so S core is length of the core divided by mu naught mu hash mu r and area core plus L core divided by mu naught A core. Okay, so length of the core is 0.376. Okay, divided by mu naught, mu r is 5000 and A core is 1.2656 multiplied by 10 negative 5. Okay, and plus L core is 0.005 mu naught 0.256 multiplied by 10 power of negative 5. Okay, so make sure the area is the same. Okay, so sorry, this one is gap, this is gap. Okay, okay, now you have to calculate this. Let me pause the video. Okay, so this is the answer. Use your calculator. So from this, okay, you get this answer. So this is S total. So make sure the reluctance at the core at the gap is much larger than the core. Okay, so you already found this, and then you get to find the flux at the gap. Okay, flux as the gap, okay, equals to flux at the core. Okay, because it is in series, you can see here. Okay, this one. Okay, core and gap is in series, and there is no leakage flux. So equals to, okay, flux is equals to B A. Okay, B at the gap and area at the gap. Okay, so B at the gap is 0.25 from here, and multiplied by the area is 1.256 multiplied by 10 negative 5. So the answer is flux is equals to 3.14 multiplied by 10 negative 6 Weber. Okay, so you have this. Okay, and now F is equals to and I equals to S flux. Okay, S total and flux. So I is equals to S total flux divided by number of turns. So 3 to 1.55 multiplied by 10 power of 6. Okay, multiplied by 3.14 multiplied by 10 negative 6, and number of turn is 400. Okay, so I is equals to So the answer is 2.52. Okay. Okay, and ampere. So that is how you solve for question number 2. Okay, number 3 is determine the magnetizing strength Hg in the air gap. Okay, so let me move this. So for question number 2, 3. Okay, so Hg is equals to B divided by mu naught only. Okay, why mu naught? Because at the air gap mu r is equals to 0. So just mu naught. Sorry, not 0 but 1. Okay, unity. Okay, so Bg you already know. Bg is 0.25. Mu naught is, okay, 4 pi divided by 10 negative 7. So you get 198,943.68 per meter. Okay, 80 per meter. So this is answer number 3. How about number 2, 4? Okay, if the flux density is reduced to half, find the new current flowing to the core. Okay, so if the flux density in the air gap, this one, flux density in the air gap reduced to half. Okay, so Bg2 is equals to 0.25 divided by 2. Okay, you get 0.125 Tesla. Flux is equals to Ba equals to 125 T, and you get, okay, find the new current. So find the new current. Let me, where is the area? Okay, so the area is 1.256 multiplied by 10 power of negative 5. So the new flux is equals to, okay, this is the answer. And then you just use the last method here. Basically you just cut the flux by half. So I is equals to S total flux number 2 and N. So basically you get 1.26. Okay, this one use the same, this one use the new one, this one is 400, the same one all. So basically your current is reduced by half. Okay, you solve. Then number 4. And the last one is, if there is no gap, find the assembly. Similar as, okay, if there is no air gap and the current value is similar as number 2 current here, what is the flux density in the core? Okay, so for this one, okay, let me adjust this. Okay, so actually for question number 5, I think no one get right actually, but I just make it lenient. Okay, some of you get a mark. Okay, so okay, for all of you, try to look at the actual method on to solve this. Okay, because this is basically more towards creative way to solve it. Okay, so you can see here there is no air gap. Okay, and you have to use the old current. I2 is equals to 2 point. Let me check first what is the current. 2 point something I think. Okay, 2.52 ampere. Okay, this is the current, not I2, just I. Okay, the current is I. So you have to be careful because there is a B max. Okay, 1.5 Tesla. So how to solve this? Of course, F is equals to Ni equals to 2.5 to 400 turn. This one you get 1008, I think. Okay, 1008 ampere turn. Okay, ampere turn. So for this case, okay, the next step you have to check back the B hash curve. B hash. Okay, and B max means that you increase, this one is almost linear until certain point it become saturated. So this is B max. Okay, so this is hash. When it comes to calculation, you have actually you have to find the hash. Okay, hash you can increase. Okay, this one you can increase, no problem, you can increase it. Okay, but the problem is at the B. Okay, at the magnetic flux density, you cannot, until certain point it will stop. So you have to calculate the hash first. Okay, not the flux, the B directly. So of course F is equals to hash L. So there is no more a gap, so F, this one hash L is just hash core and the L core. So hash is, okay, hash core is equals to F divided by LC. So F is what? F is 1008 divided by the length 0.376. Okay, let me use the calculator. So you get 2680.85. Okay, and of course from this you have to find the B. So how to find the B? B is equals to mu not mu R has C. Okay, so mu not mu R, mu not. Okay, mu R is 5000, C is 2680.85. Okay, so you get 16.84. Okay, Tesla. Okay, you can see here B max is actually 1.5 Tesla only. So what is the flux density of the core? So basically, if you can see this, okay, it should not be more than 1.5. So basically B is just equals to 1.5 Tesla only. Okay, so this is the correct step, but if you use the P equals to flux divided by A, this one is also acceptable. Okay, no need to worry. Okay, so that's it. That is how you solve this question, and make sure you check back and try to improve your knowledge. Okay, that's it. So see you again at the next video.